Hey everyone, can anybody guess where I am? I'll give you a clue. This city has 1.568 million people in it. In case you don't recognize the city, I'll give you another hint. I'm in Philadelphia, the city of brotherly love. When you think of Philadelphia, you may think about the Liberty Bell and Independence Hall, where the Declaration of Independence and the Constitution were signed. You may also think about the Philadelphia Eagles. This might not be your first Eagle that you think of. Maybe you're thinking of the Super Bowl champs. All of you Dallas Cowboy fans, I'm sorry. Actually, I'm in Philadelphia with a volleyball tournament. That's my daughter. She's the tall one jumping over the net. Today's lesson is 10.1, Introduction to Conic Sections. The objectives for today: you're going to be able to recognize conic sections as intersections of planes and cones, and you're going to be able to use the distance and midpoint formulas to solve problems. The vocabulary for today is conic section. In Chapter 5, you studied the parabola. The parabola is one of a family of curves called conic sections. Conic sections are formed by the intersection of a double right cone and plane. So it's actually a double cone. There are 4 types of conic sections: circles, ellipses, hyperbolas, and parabolas. Although the parabola you studied in Chapter 5 are functions, most conic sections are not. This means that you often must use 2 functions to graph a conic section on a calculator. A circle is defined by its center and its radius. An ellipse is an elongated shape similar to a circle. It has 2 perpendicular axes of different lengths. Remember, when you take the square root of both sides of an equation, remember that you must include a positive and a negative roots. Example 1 says to graph each equation on a graphing calculator. Identify each conic section, then describe the center and intercepts. So before we can get it into our graphing calculator, we need to solve for y so that the expression can be used in the calculator. All right, so we're going to set it equal to y. So my goal is then to have y equal something. So if I subtract x minus 1 squared from both sides minus x minus 1 squared from both sides, that's going to help me. All right, so now I don't have my y by itself yet, so I need to go ahead and for my next step, I just want to take the square root of both of these pieces. All right, and when I do that, I end up with y minus 1 equals plus or minus the square root of 1 times x minus 1 squared. Once I've done that, I can simply add 1 to both sides, and I end up with the equation y equals 1 plus or minus square root of 1 minus x minus 1 squared. That's a mouthful. All right, so continuing on with this, step 2, we're going to use the 2 equations to see the complete graph. So what I need you to do is in your calculator, in y1, you're going to put 1 plus this whole thing. In y2, you put in 1 minus the whole thing. And then you want to use a square window on your graphing calculator for an accurate graph. All right, the graph meets and forms a complete circle, even though it might not appear to be that way on the calculator. The graph is a circle, and then you're told to describe the center. And so we can see that the center is at 1, 1, and then we tell about the intercepts. We have an intercept at 1, 0, and an intercept at 0, 1. And of course, the great thing about math is you can use a table to confirm your intercepts. Just looking at your table, we can see we have when x is 0, y1, and y2 are both 1. All right, here's another example. Again, we're going to graph the circle and ellipses on a graphing calculator. And so this time we're going to have an ellipse. So the first thing we need to do to get this on our calculator is we're going to solve for y again so that the expression can be used in a graphing calculator. So in order to solve for y, let's subtract 4x squared from both sides. All right. And once we've done that, we end up with 25y squared equals 100 minus 4x squared. The next thing we want to do is divide both sides by 25. All right, and when we do that, we end up with y squared equals 100 minus 4x squared all over 25. Now, we still don't have what we want. We don't have it plain y. We have y squared. So remember, in order to solve for that, we're going to need to take the square root of both sides, and we end up with y equals plus or minus. So notice we're going to have to put in your calculator both the plus and the minus. All right, so continuing on, step 2, we want to use the two equations to see the complete graph. So y1, you're going to put in the positive. y2, we're going to put it in as negative. All right, so I want you to use the square window again on your graphing calculator so you can see an accurate graph. The graphs meet and form a complete ellipse, even though it might not appear that way on the calculator. All right, and the second part of your assignment here is to tell what it is, what shape it is, and so we can see that it's an ellipse. The center is at 0, 0, and then we need to look at our intercepts. This time, notice my intercepts when x is positive 5 or negative 5, the y is 0, and when x is 0, y is positive 2 or negative 2. And of course, you can use your table to confirm your intercepts, and there it is. All right, so here's one for you to try on your own. Mr. Stewart, if you would so kindly turn the video off for just a minute and let everybody give it a try. Okay, so I hope that you found the very first thing that you should do. Step 1 is to solve for y. So what we're wanting is to have y equals something so we could put it into our calculator. And so I think the easiest thing to do would be to subtract x squared from both sides. Now notice I still have this y squared, so we're going to need to take the square root of both pieces. And when we do that, we have y equals plus or minus the square root of 49 minus x squared. Step 2, we're going to use these two equations in the to see the complete graph. So in your calculator, you should have put y1 equals the positive, and y1, you should have put that negative sign in also. All right, and once you do that, if you use a square window on your graphing calculator, you can get a more accurate graph. The graphs meet and form a complete circle, even though, like in this case, you see that it doesn't actually show it on the calculator, but it is a complete circle. All right, you should have described that this graph is a circle with center at 0, 0, and the intercepts when x is 0, y is positive 7 and negative 7, and when x is 7, y is 0, and negative 7, y is also 0. And of course, use your table to confirm the intercepts. All right, here's another one for you to try on your own. So Mr. Stewart, if you would please turn the video off for just a minute and let everybody give it a try. All right, so I hope you noticed that the very first thing we need to do is solve for y so that the expression can be used in a graphing calculator. And remember, what we want is to have y equals something. All right, so right now, if I subtract 9x squared from both sides, that's going to be helpful. So let's go ahead and do that. And when we do, we end up with this. Next, we want to divide both sides by 25. All right, so now notice that I'm almost there. I've almost hit my y, but I have y squared. So let's take the square root of both sides. And when I do that, I end up with y equals plus or minus the square root of 225 minus 9x squared over 25. So for step 2 in y1, I want you to put y1 equals the positive of it. In y2, put the negative part in it. Again, use the square window on your graphing calculator for an accurate graph. The graphs meet and form a complete ellipse, even though it might not appear that way on your calculator. Okay, the graph is an ellipse with a center at 0, 0, so you'll need to include all this information. All right, and the intercepts when x is 5 and negative 5, y is 0. And when y is 0 when x is 0, y is plus or minus 3. Again, you can use a table to confirm this. All right, so let's now move on to the parabola. A parabola is a single curve, whereas a hyperbola has two congruent branches. The equation of a parabola usually contains either an x squared term or a y squared term, but not both. The equations of the other conics will usually contain both x squared and y squared terms. All right, and you can kind of see why that would be true. All right, so a helpful hint. Because hyperbolas contain two curves that open in opposite directions, classify them as opening horizontally, vertically, or neither. All right, let's try an example on this one. We're going to be graphing parabolas and hyperbolas on your calculator. So again, the very first step that we want to do is solve for y so that the expression can be used in your graphing calculator. Well, unfortunately, this problem was already solved for y. We already have y equals negative 1/2 x squared. So based on what your information that you know so far, you should have an idea of what that's going to look like. So let's use your calculator to put that in, y1. And when you do, the graph is a parabola with a vertex at 0, 0, and it opens downwards. So this is the information you'll need to be able to tell about that. All right, example 2. Notice on this one we have x squared and a y squared. So the very first thing we want to do is solve for y so that the expression can be used in the graphing calculator. So if we add x squared to both sides, we end up with y squared equals 9 plus x squared. Notice I have a square here, so I'm going to have to take the square root of both of these pieces so I can get y by itself. All right, so once I do that, notice I have y equals plus or minus. So let's move on to step 2. Step 2 says to use the two equations to see the complete graph. So you're going to put in y1, the positive of it, and y2, be sure to put your negative in. All right, now the graph is a hyperbola that opens vertically, and the vertices are at 0, positive 3, and 0, negative 3. So all this information is information you'll need to be able to tell. All right, here's one for you to try on your own. Mr. Stewart, if you'll turn the video off for just a minute and let everybody give it a try, that would be great. All right, so here we are to graph each equation on the graphing calculator. So in order to do that, the first thing we need to do is go ahead and solve for y first so that we could put it into y equals. All right, so our goal, remember, is going to be y equals something. So right now we have 2 with it, so we need to divide both sides by 2. And we end up with y squared equals 1/2 x. Remember, we still have to deal with this little square here. So if we square both sides, take the square root of both sides, we end up with y equals plus or minus 1/2 x, square root of 1/2 x. All right, step 2, you want to use the two equations to see the complete graph. So we're going to take y1 in your calculator, and y1 is going to be plus, y2, don't forget to put your negative sign in there. And when you graph it, you are going to see that you get a parabola, and you are to tell me the graph is a parabola with vertex at 0, 0, and it opens to the right. Again, on your own, try this one on your own. Turn the video off and give it a try. Okay, so on this one, once again, the very first thing we need to do is solve for y so that the expression can be used in your graphing calculator. This one, I would do it a little bit differently. So let's see, subtract x squared from both sides. So minus x squared from both sides. And now we still have 2 problems that we have to take care of, that negative and the square. So let's multiply both sides by -1. And then the next thing we want to do is distribute that -1 to everything so that make sure you remember that negative goes to both of these pieces, which gives us this format here. All right, once we distribute, now we can rearrange it to have it in the order that we like it. And finally, take the square root of both sides. So plus or minus. Oh, my X didn't get in there. Step 2, we're going to put in y1, this, and in y2, don't forget to put your negative in, and you will see that it's a hyperbola. And the information you need to say is this graph is a hyperbola with vertices at x is negative 4, 0, and positive 4, 0. And it opens horizontally. Every conic section can be defined in terms of distances. You can use the midpoint and distance formula to find the center and radius of a circle. This chart can be found on page 724 in your textbook. So if you have forgotten the midpoint formula, or if you have forgotten the distance formula, remember the distance formula is just a takeoff on the Pythagorean theorem, then you might want to bookmark this page and keep it in mind. We'll go ahead and do some problems using these two formulas. So let's just keep on going. All right, so let's think about why we're going to be using the midpoint and the distance. Because the diameter must pass through the center of a circle. The midpoint of a diameter is the center of the circle. The radius of a circle is the distance from the center to any point on the circle. All right? And it's equal to half of the diameter. So if this is our diameter, the radius is half. You guys know all of this. All right, so here's a helpful hint. The midpoint formula uses averages. So you can think of the midpoint xm as the average of the x values and ym as the average of the y values. Just something that might help you, it might not. Using the formula on, or the formulas, on page 724 will probably be the most helpful. All right, let's do an example with finding the center and radius of a circle. In this case, it has a diameter with endpoints at 5, 4, and 0, negative 8. So let's just talk about for a second what that's going to look like. All right, so if I have a circle and I have a diameter going through it, all right, and I know these 2 points right here, if I just find the midpoint of it, I'm easily going to find the center of my circle. All right, so let's review what our midpoint formula is. So remember, the midpoint formula is going to be x1 plus x2 divided by 2 and y1 plus y2. Remember, we talked about that being an average divided by 2. So 5 plus 0 divided by 2, and then 4 plus negative 8 divided by 2, and we get 2.5 and negative 2. So there's our center. Okay, so the second step of this problem is to find the radius. So let's remember what our radius is. If I have a circle and I have a radius there, if I take this point and find the distance, that will tell me what the distance of my radius is. And so what we need to do is use our distance formula. Remember, this is going to be x1, y1, and x2, y2. So if we take our x1 minus x2, it's our 2.5 minus 0, and square that, and then our y1 minus y2. And remember, notice it's negative 2 minus a negative 8, so it ends up being a positive 8. Square that, we end up getting 6.5. So the radius of the circle is 6.5. Okay, finally, again, I love math because we can always check and find out whether we are correct. So we could just substitute the other endpoint, 5, 4, and using the same center again. So then once you do all the distance formula again, you should find out that the radius is the same of 6.5. All right, so let's try this example. Find the center and radius of a circle that has a diameter with endpoints 2, 6, and 14, 22. So turn the video off for just a minute and give it a try on your own. All right, so I hope that you realize the very first thing, in order to find the center, we're going to use the midpoint formula. And remember, the midpoint formula says take both of your x's and add them together. x, and add them together and divide by 2. And your y's, add those together, divide by 2, and we end up with a radius or a center point of 8, 14. Step 2, we're going to need to find the radius, so we're going to use the distance formula. All right, so step 2, we're going to find the radius. Remember, in order to find the radius, we're going to need to use the distance formula. And again, we're just going to take 8 minus 14 and square that, plus 14 minus 22 and square that. And when we do, we find that the radius of the circle is 10. Again, you can check your work by filling in with the other endpoint, which was 2, 6. And again, you'll find that the radius should be 10. And that's the end of today's lesson. Thank you, Mr. Stewart, for being our substitute today. Here's your assignment. You guys work hard, and I'll see you in class on Wednesday. Have a good day. Bye.